Um, First of all, I have checked with my team that your assignment 4 and practice assignment 4, week 4 content will be aired around June 20 only. So before that, we can discuss what are the things that we covered till week 3, and that will be useful for quiz. And we will see some problems from week 3 now, because the last week most of the people have not joined. So I wanted to show some of the problems that will be useful for your quiz, right? I hope my screen is visible, right? Okay, good. So if something happens, or if I go, if my screen is not presenting properly, just let me know. Turn on your mic and let me know. Okay. Right. We will try to solve some problems, and I will let you solve similar problems so that we can learn together. First problem is that, so as far as you know, the week 3 contents broadly covers Laplace transforms and inverse Laplace transforms and all, impulse response, how to find impulse response, and damping ratio around natural frequencies, that second order system classifications and all. So this problems will be based on this, and this will also be help you to solve week 4 problems also, because the week 4 broadly covers the difference between the first order system and the second order systems. Okay, so the first question is about finding the Okay. The first question is about finding the impulse response of any system given the transfer function. So we already know transfer function will be the Laplace transform of output by Laplace transform of input. So always the transfer function will be mentioned in terms of S. Okay. So here there is the top numerator, we call it as zeros, and the denominator we call it as poles. So the poles determines the stability of the system, and also this poles is the characteristics equation. You can find the poles of a system from the characteristic equation, that is equating the denominator to 0. So that you will get the poles. Poles are nothing but the factors of the system, right? So everything of this we have seen so far is interlinked to each other. Just for an introduction, I told that. Right. Now we have the transfer function in our hand. We have to find the impulse response of the system. Okay. The first thing what you can do is impulse response, in the sense you will always have to find the time domain characteristics of the system, or time domain representation of the system. So first, if you want to convert it from S domain to time domain, what you will do? You will use inverse Laplace transform. Right? So in the other way, if you want to convert the time domain to S domain, you will use the Laplace transform. So now it was asked to find the impulse response y of t in terms of t time domain. We are now going to use the inverse Laplace transform for this. Okay, this is the first step of knowing how to solve any problem. Okay, right now. First, if you want to find the Laplace inverse of this problem, s plus 1 into s plus 10, so first you have to factorize the system. Since it is in the multiplication, we are now going to factorize the system. How we will factorize? A by s plus 1 plus b by s plus 10 equal to nothing. So we will keep it as 1, the numerator. So this will become a into s plus 10 plus b into s plus 1 is equal to 1. So if I put s is equal to minus 10, this terms will go to 0, and this will be minus 9, b is equal to 1. This gives b equal to minus 1 by 9. If I put s is equal to minus 1, this will become 9 into a is equal to 1. So this gives a equal to 1 by 9. Right? This will give a equal to 1 by 9. Now we know what is a and what is b. A is 1 by 9 by s plus 1 minus 1 by 9 by s plus 10. Am I right? Is there any mistakes here? Anybody told anything? Fine. So I hope there isn't any mistake. So we have y of t is equal to 1 by 9 by s plus 1 minus 1 by 9 by s plus 10 right now. So if I want to take a Laplace inverse of this, 1 minute. So if I want to take a Laplace inverse, 1 by s plus a, this will give you e power minus at. So this will be 1 by 9 into e power minus t minus of 1 by 9 into e power minus 10t. This is your answer. Any doubt here? Right. So can you try solving this question? Same question, instead of s plus 10, I have given s plus 3 the whole square. Can you try solving this question and give me the answer? There is nothing difference, there will not be any difference. While doing the partial fraction 1 by s plus 1 into s plus 3, you have to take a by s plus 1 plus b by s plus 3 plus c by s plus 3 the whole square. That's it. This is the only difference you have to make. So you will get 3 terms in the y of t. Can you try solving it plus or minus something? Right? Instead of this 2 term, e power minus t into e power minus 10t, you will get e power minus t, e power minus 3t, e power minus 8t something, t into something you will get. So that is the main difference. Just try to solve it and by using the properties of Laplace transform. Once you solve it, let me know or put the answer in the comment section. Otherwise, if you have any difficulties, let me know. Okay, I will help you. I will wait until you solve. Okay, I will put that as a screen. Just turn on the mic or open the comment section and tell whatever problem you are facing. Okay, those who join now, I have asked the people to solve this question and to find the impulse response of the system. So you can also join to solve this. If you face any difficulties, let me know, I will help you. Otherwise, solve and put the answers in the comment section, sorry, the chat box. The steps to solve this is, first you have to do the partial fraction. The partial fraction I have given here. Find a, b, c value and write it in terms of this and take the inverse Laplace transform. Use properties of inverse Laplace transform. You will be able to get the answer in terms of time domain specification or time domain representation. were able to solve? Anybody who has solved? No, CS plus D won't come because CS plus D will come if the denominator looks like this. Otherwise, it will be like this one. There won't be any S. If the denominator is of power, you have to write like this one. B by one factor without power plus C by another factor with power. If you have solved, please put it in the chat box as done. Okay, you are getting A, B as C and C as this. Anyone else getting the same answers as Shamila? Yes, okay. It might be correct. We can also solve this. So this will be A into S plus 3 plus B into S plus 3 the whole square, B into S plus 1 into S plus 3 plus C into S plus 1 is equal to 1. And if I put S is equal to minus 3, this will go out, this will go out, this will be minus 2 into C, minus 2 is equal to 1. This gives C equal to minus 1 by 2. Right. If I put S is equal to minus 1, this will be 4A plus this will go out, this will go out. 4A is equal to 1, this gives us 1 by 4, A equal to A. If I put S is equal to 0, 9A plus 3B plus C is equal to 1. So this will be 9 by 4 plus 3B minus 1 by 2 equal to 1. 9 minus 2 by 4 plus 3B equal to 1. 7 by 4 plus 3B equal to 1. This will be 3B equal to minus 7 by 4 minus 3 by 4. B equal to minus 1 by 4. So A equal to 1 by 4, B equal to minus 1 by 4, C equal to minus 1 by 2, right? Everybody is getting this? Can you give a thumbs up? Right. So if we write it like this, where it was A by S plus 1, right? So 1 by 4 by S plus 1 minus 1 by 4 by S plus 3 minus 1 by 4, sorry, minus 1 by 2 by S plus 3 the whole square. This will give you e power minus t 1 by 4 minus 1 by 4 e power minus 3t minus 1 by 2t e power minus 3t. Am I right? now you will be able to find the impulse response if I give any transfer function. This is done. The second thing I want you to learn is how to find a damping ratio or natural frequencies or anything if I give you a transfer function. First of all, connect it with the standard transfer function representation of a second order system. So every time when we want to let you find this, it will be a second order system. Keep that in mind. So compare this with the standard second order system transfer function, which will be represented as s square 2 zeta omega n s plus omega n s square. So if I compare these two, omega n square is equal to 64, 2 zeta omega n will be equal to 8. So this gives us omega n equal to 8. So if I substitute here, 2 zeta 8 is equal to 8, 8 will get cancelled, 2 zeta equal to 1, zeta equal to 1 by 2. Okay. And you know that omega d damping frequency will be omega n into root of 1 minus zeta square. When you substitute this, 8 root of 1 minus 1 by 2 square means 1 by 4. This will gives you 8 into 4 minus 1 root of 3 by 4. Calculate this, okay. That will be your omega d. So you will, if you are given with a transfer function and you will be able to find this. This is one step. This is one type of problem. Another type of problem we can ask this is whether this is a overdamped, underdamped, or undamped or critically damped system. We are very well known about this. Every time I used to tell this. This is zeta greater than 1. Underdamped means 0 less than zeta less than 1. Undamped means zeta less than 0 or 1. Less than 0. Critically means zeta equal to 1. Okay. So here you find zeta equal to 1 by 2, that is 0.5. So how will you classify the system? Under which partition or classification this will come? Can you type it in the chat box? Under damped system. Very good. Right, Manisha, are you with me? Alkesh, Manisha, you people are with me? Right. There is no doubt in this, right? Okay. So this is a second type of problem. While giving a transfer function, you might be asked to find the components, or you might be asked to classify whether it is a underdamped, overdamped, or the system types. Okay. We have completed 3 sums. Then comes the transfer function. Another set of problem would be finding the transfer function. So far we have given the transfer function and asked you to find the other related things. Now we have given a system and asked you to find the transfer function. This is very straight away problem. You just have to use KVL, KCL, whatever it is based on the system. And if it is a mechanical system, use this whether m square acceleration into acceleration plus b into velocity plus x position. So you will be asked to find the dynamic equation related to this. Just apply KVL to the system, write the equation, mathematical equation based on this electric circuit, and try to convert it into the transfer function like Laplace transform. For example, the most commonly known is if it is an inductor, it will be L square dI, L into dI by dt. So if I want to convert this into a transfer function, so you have to find the properties, that is dx by dt. Laplace of dx by dt will be x of s minus x naught, right? So that's it. So this will be L into I of s minus I naught, where I naught will always be 0. Initially the current will be 0, then this will be L into Is. That's it. So similarly for capacitor, how it will be 1 by C into dV by dt. So this is the current equation you will get. Integral I dt, right? So this will be just find the properties of Laplace transform for the integration and replace it with that's it. So based on this R will be straight away that R into I of S, that's it. It's a kind of constant. There is no energy storing element there. So the degrees will be based on these two. That's it. Once you write all these things, combine everything based on whether it is a series circuit or parallel circuit, you will be able to write the Laplace transform. That's it. If that is a Laplace transform of output by Laplace transform of input will be your transfer function. Okay. Right. Then this is another straightforward question I want to solve. This is based on only the Laplace transform as I said here. Just straight away use this formula. This will be d square c of t by dt square plus 2dc of t by dt equal to r of t, where you can relate that c of t is the output and r of t is the input. If I want to find the transfer function, I have to find L of c of t by L of r of t. Right? This will be c of s by r of s. That's it. You want to find this, just take everything to the left side, whatever there in the numerator, rest of the things in the right side. So if you want to write the Laplace transform for this is in the second order, right? So Laplace transform of this would be s square x of s minus x0 minus x dash of 0. Sorry, it is in terms of c, right? S square c of s plus c of 0 minus c dash of 0. Consider, if nothing given, consider all the derivatives to be 0. So this I will be left with only this part. For the next part, plus 2 into s of c of s is equal to r of s. That's it. So combining everything c of s together to one side, s square plus 2 is equal to r of s. And we want this format, so c of s by r of s is equal to 1 by s square plus 2. That's it. This is the transfer function of the system. Either these are all the two types of another set of questions where you will give either the system or the representation of the system and you will be asked to find the transfer function. So for this you should know what are all how to solve this circuit, basic electric circuit problems for R, L, C. Just find that and write it in terms of using the KVL equation, then apply Laplace transform, you will be able to write the transfer function. Here straight away use the properties of Laplace transform and you will be able to write the answers for the transfer function. So far, any doubt? If you have any doubts, please turn on your mic and ask. Yes, yes. Oh, sorry, I missed it. Yeah, right. Yes, square plus 2. Yeah, right. Objective only. Objective, computer based. But for finding the objective answer, you will be able to solve at least 4-5 steps based on the marks. There are 2 marks, 4 marks, 6 marks questions. So based on the marks, you will be able to solve that many steps. Okay, right. So this is an example problem as I told before, where you want to find the zeta, omega in omega d. So can you solve this and say whether this in which classification this system will come under? Please put it in the chat box. getting undone. Okay, good. Right. So we'll be getting something lesser than 0, right? Oh, sorry. Will be between 0 to 1. The zeta might be between the 0 to 1. It's good. Okay, right. That's it. Okay, these are some of the problems, and we have solved some problems last time also, I guess. Okay, so these are all the problems I want you to solve from week 3. Yeah, Srivastava. Oh, this one. Yeah, I will see. Okay. Just compare it with the standard transfer function of the second order system. So this will be omega n square is equal to 100, omega n will be equal to 10. If you compare the denominator is 2 zeta omega n, n equal to 2. Omega n you already know 10, 2 zeta is equal to 2. Cancelling 2 to zeta will be equal to 1 by 10, that will be 0.2. So this will comes under the range of 0 to zeta less than or equal to 1. So this belongs to 100 amp system. So if this value comes lesser than 0, this will be undamped, or equal to 1, this will be critically damped, or greater than 1, it will be equal to overdamped. That's it. Okay, right. So these are all the sums that I wanted to share with you from week 2. And since we have some time, we can solve some of the problems from week 2 also. So far we solved from week 3. We can solve few problems from week 2 also, so that you will get some practice for the quiz. I'll choose few questions and tell you. Give me a minute. There will be some easy questions also, okay? If you know the concepts, you will be able to answer those. There are questions like that. There are medium questions and there will be hard questions. So try solving this tutorials or practice assignments and assignment problems. You will be able to score well. We'll start with like basic things in Laplace transform. Just find the Laplace transform of e power 2t cos 3t. Okay. What you will do first? It's in time domain. We have to convert it to the S domain. Just we will use the Laplace transform. It's already there in the question, straight away question. Just we want to find the Laplace transform of these two. That's it. So first what we can do is Laplace of e power 2t cos 3t. So if you know the properties, that is very good. You can straight away answer this question. Otherwise, try this cos of 3t at s is equal to minus 2, because there is a e power minus 2t terms. So the property will tell e power minus at cos bt. This will be s by s square plus b square at s is equal to s minus or s plus a. Right? This will become s plus a by s plus a. Wherever there is s, it will be replaced by s plus a, because there is a minus here. If this is a e power at, it will be replaced by s minus a. That is the difference. Right? B square. So since it is this is s minus 2. So this will be cos 3t means cos 3t, how will you write? S by s square plus 9 at s will be, wherever s is there, it will be replaced by s minus 2. Then this will be s minus 2 by s minus 2 the whole square plus 9. That is the answer. Correct? So similarly, if I want to add a little bit more complexity to this, I will ask you to solve Laplace transform of t into e power 2t cos 3. Can you solve this? What else we have to replace? Think about it. There are one extra term, that is t here. Hint will be, you have to use frequency differentiation property whenever there is a t. How it will look like? So we already found this s minus 2 by s minus 2 the whole square. For this term we know, plus 9. We already have this. Just you have to do a Laplace transform of t in before this. So what this frequency differentiation property will tell us? You just have to differentiate this and put a minus behind this, before this. Right? S minus 2 by s minus 2 the whole square plus 9. I have just used the last problem to solve this. This much complicated thing we won't ask. You will be asked maybe using the sin t. So there will not be any s term above. So you can just differentiate it easily. Right? Just remember that whenever there is a t, when using a Laplace transform, we have to add this term to the existing. That's it. Okay. We have already solved this problem before. I will give you a little bit advanced version of this. See if you can solve this problem. I will help you anyway. One minute. Can you solve this problem? I will give you 0, y dash of 0 is equal to. Right? So e power minus t sin t would be, as we already saw, first we have to solve for this. Sin t will give you 1 by s square plus 1 at s is equal to s minus. Since there is a minus, we are going to replace it with s plus 1. Then wherever there is s, you have to replace it with s plus 1. S plus 1 the whole square plus 1. So this e of sin t will be equivalent to this. Just replace, use all these formulas and replace this line with this and tell me, or you can tell the answer itself. Just try solve it by yourself without my help primarily. Otherwise, if you need any help, ask. Initially solving problem by yourself will be tough, but once you try solving it and you will get a joy of solving it, then everything will be like this. Anybody solved? Rahina, you have asked something? I don't understand. You are able to solve? Anybody is struggling with this? Can you raise your hand? I will help you. Shall we solve together? I will write s square into y of s minus y naught plus 0, so this term will be 0, this term will be 0, y dash of 1 is equal to 1, so I am going to write only 1. This is for first term. The next term I am going to write for 2y dash, that will be s into y of s minus y dash of 0 is again 0, plus 5 into y of s, because y of t is equal to y of s in Laplace. The right hand side I am going to replace it with this s plus 1 the whole square plus 1. Right, now we will have, just keep the y of s as constant. This will be s square plus s plus 5. So this time I have taken this, the rest of the thing is minus 1. Just keep it outside because it is not common with y of s. It's equal to 1 by s plus 1 the whole square plus 1. So this will become, what is this? Oh, this 1 will go this side. So y of s into s square plus s plus 5 is equal to 1 by s plus 1 the whole square plus 1 plus 1. So this will become s plus 1 the whole square plus 1 by, am I doing any mistake here? Oh, sorry, plus, right, yeah, right. This will be 2 is, so there is a 2 term here, right? So I must put. So I'm taking 1 here, already there is 1. This will become 1 plus this, s plus 1 the whole square plus 1. This will be s square plus 2s plus 1 plus 2. It becomes 3. I am going to write as it is. Plus 3 by s square plus 2s plus 2. Okay, we have y of s into s square plus 2s plus 5 here. I think this should be easily cancelable. Again, I have made some mistakes somewhere. Oh no, that's fine. Okay. Y of s is equal to s square plus 2s plus 3 by s square plus 2s plus 2 into s square plus 2s plus 5. So this should be your final answer. Anyone not getting this answer? Okay, if you need any help, please let me know. Yes, Sriyasura? Yeah. Yes. This one, right? Okay, fine. Okay, fine. So I will take this here and put it down so that it will be easy to explain. Look at it. Okay. See, if we are going to do term by term, okay? Consider this as a first term, second term, and third term. For first term, we have given the explanation here. Laplace transform of y double dot or d squared y by dx square, both are same, or dt square, both are same. So if we take Laplace transform of this, you will get the right hand side of this. So if I want to write it for the first term here, I will write it as s square y of s minus y of 0 minus y dash of 0. This is for first term. So the second term I will write in different color 2. So for this you will write this part. So Laplace transform of 2y dash, you will get this 2 into whatever is there for the y dash, that is s into y of s minus y of 0. For the third term, I am writing with black, this is the third term, plus 5 into y of s, right? Is this clear till now? Right. Now we are going to substitute whatever value they have given here. They have given value for y equal to 0, y dash is equal to 1. So wherever y equal to 0, put 0. Y dash is, wherever y dash, put 1. So here we are going to write it as s square into y of s minus 0 minus 1 plus 2 into s into y of s minus 0 plus 5 into y of s. That's it. So this will give you s square y of s minus 2s y of s plus 5y of s minus 1. That's it. So I'm going to club all these things together. Since y of s is common, this will give you s square minus 2s plus 5 into y of s. This one will be separate since that y of s is not common for it. Is it clear now really? Good. We'll move on to some other problem that is little bit different from this. You all know initial value theorem, final value theorem, right? Just touch upon this when you go for the exam. This could be one potential question because this is a important theorems in the control systems concept. Can we solve one electrical, that circuit based problem if you struggle with that? Right. So we will solve this problem R L C. So I am taking RLC circuit where can you type what is input and output here? What is the input, what could be the input and what could be the output here? If you know that, it will be easy for you to write the transfer function. Can you all type? Right. Good. There is no VC. So the input is VI. VA is the input. Good. VC. Oh, okay. Understood. The voltage across the capacitor you are telling. VC or VO is the output here. So when we want to write a transfer function, keep that in mind. Laplace of output by Laplace of input. Then this will be Laplace of V naught by Laplace of VA. So how can I write it? It will be V naught of S by VA of S. So this should be a first step. Whenever you are asked to find a transfer function, just try to find the output and input and write in terms of numerator and denominator. Laplace of output by Laplace of input. So this will let you solve the problem easily. So next thing. So we are going to write the dynamic equation of this system. We are going to apply KVL to the system, and we'll try. So if voltage is there from positive and negative, current will start from negative and goes to the positive side, right? So the current direction will be this, like this arrow. I am calling this current as I of t. Similarly here, I of t. This is the direction of the current. So always we will start from minus. So if this is plus, this will also be plus minus if we want to write it. Okay, so this will be minus Vi plus R into, how will I write? IR. So I of t, R into I of t plus L into dy by dt, right? This will be one equation, will be equal to C. Clear? Any doubt on this? The next what is that? Parallel thing, how you can write this will start from minus L dy by dt plus 1 by C into integral I of t. So just this is a familiar thing, just replace this with this. Since if you take it outside, if this will be L dy by dt will be equal to 1 by C into integral I of dt. Replace this term with this, that's it. So overall you will get an equation that this part and this part. Yeah. Okay, I think I have made one mistake here. Yeah. We can solve it easily. Why I did this? Okay. Right. Maybe leave this. Yeah, you are right. Just I think since it is a parallel circuit, there is a node here. We can solve it using the voltage divider rule, right? That will give you a straight away answer why we want to solve two different equations. Right? The voltage divider rule will tell wherever the current pass, that current divided by sum of the resistors or capacitors or energy storage elements there into output voltage is equal to the current energy storing element divided by sum of the energy storing elements in the circuit. Anybody doesn't know this voltage divider rule? Should I explain it? Oh, okay, can you? This is mistake. Don't follow this, okay? I made a mistake here. Very good. So we have seen it from here. So how can we solve this? We can consider this both circuit as a single circuit and this as the current energy storing element, right? So we can write it as in terms of, these both are in parallel. So L parallel to C divided by R plus L parallel to C into VL. Is it right? Have I done any mistake here? This is right? I'm not confused. Good. So now, since L and C are in parallel, we are going to take a Laplace transform as it is. Thus, that will give you L by C into Ls plus 1 by C into S divided by R plus the same term, whatever we have written here, that will come. Right? Good. Now we have what in common? We have L by C above, that is in common, and if we take if we cross multiply it here, we will get L by C as in the denominator This will be RC into LS plus 1 by CS. The CC will get cancelled here. Then this will give you R into LS plus 1. So R into LS plus R by S, right? Have I missed any C? No. Plus L. Whole this denominator will get cancelled totally, right? This L and this L will get cancelled. You will be left with L by C divided by S square into RLC plus R plus S by CS. So this and this C will get cancelled. Then you will get SL by S square RLC plus R plus S into. So if we put VA here, V0 by VA, this you will left with SL plus S square RLC plus A. Right? So this is your transfer function, overall transfer function. I hope this is correct. Let me check the answer. Yes. Yeah. Okay. So thus when you are asked to find given a system, electrical system, try to do KVL, or sometimes if the circuit is straight away as a parallel circuit with the two different nodes or the single partition, you can straight away use the voltage divider rule instead of calculating for each node. We cannot use, we have to use nodal analysis there. Instead of complicating this, just try to use the voltage divider rule straight away. That will be easy. Okay. And I will share one more problem, then we can discuss if we have any doubts, otherwise we can wrap it up. Yeah. Okay, right. One minute. I will explain. Here we are taking a we are giving an input voltage here, right? So whenever we are writing voltage divider, so there are two rules, right? Voltage divider rule, current divider rule. So for voltage divider rule, for both, like I will make it easy, current divider rule, okay? For both, the denominator is same. That is the sum of the energy storage element in the parallel path. For example, if this is one partition, this will be the second partition. So I'm considering this as a one part and considering this as another part. For voltage divider rule, both denominator will be same. For example, this will be R. Okay, let me write in a different way. Okay. For voltage divider rule, the denominator will be R plus, since this L and C are in parallel, I am considering it as a parallel. We will expand it later. For simplicity, I am keeping it a parallel as it is. For current divider rule also, this will be same, R plus L parallel to C. If these both are connected in series, then it will be L into C, that's it. Since it is in a parallel combination, both are in parallel combination, I am writing it here. For voltage divider rule, the numerator will be this term, L into C. For current divider rule, this will be this term, that's it. That is the difference between these two. I hope this is clear. Right? This will be in output current equal to input current. This terms into input current. Here it will be output voltage in terms of input voltage. Okay, so we are going to apply voltage divider rule here since our output and input are in terms of voltages. So that's why I have written it here. Just expand it in terms of Laplace transform. So if you write a Laplace transform for the circuit, first if both the elements are in parallel circuit, how you will write L into C by L plus C, right? So for a Laplace transform of this will be L di by dt into 1 by C into integral I dt divided by L di by dt plus 1 by C integral I dt. So this is a different, I am solving it right now. By dt. So if we take Laplace transform, this will become L into S into I of S, plus this will become 1 by C into I of S, or 1 by CS into 1 by S into I of S, this will be divided by Ls of I of S plus 1 by Cs of I of S. So if I take all I of S common, sorry, this is multiplication. So if I take everything common, this will be Ls by Cs, Ss will cancel, L by C divided by Ls plus 1 by Cs. That's what I have written it here. L by C, these terms will come here. So after that you just have to, I think my AirPods battery went down. Can you hear me now? Yeah, okay. Oh, just after that it's very mere simplification, that's it. So you will end up having this.
Yeah, got it. Thank you.
Oh, thank you. So the next thing, I want to share some small questions also. Okay, I will list out what you can prepare once. First, try to understand basic systems. For example, what is cruise control, mechanical systems, pendulum. These are some standard systems that is in control systems. Inverted pendulum, how to write dynamic equations for all these things. There are plenty of materials available online that will easily explain it to you. Otherwise, the slides itself is enough. You can go through the first week slide, you will get all those information here. Right, any segues, these are a little bit advanced, but no need, but just know how to write it. And rotational systems. If this is a mechanical system, this involves M, B, X and all. If it is a rotational system, it will be mentioned in terms of moment of inertia, angular positions and all. This is linear position, this is angular position, that we call it as rotational systems. Then electrical systems, that involves all this V, I and all, right? Just revise these basic systems. Then what you can go is some basic laws of prey predator prey systems. These are some standard control system concepts. Then understand what is KVL, this voltage divider, and all that will be helpful. And how to write a mechanical system dynamic equation, rotational system dynamic equation, what is the consideration you need, and similar to that. For based on week 2, week 2 itself is started with Laplace transform, right? These are all important concepts. Laplace transform, inverse Laplace transform, properties of Laplace transform, then initial value theorem, final value theorem. Potential questions will be there from this. Then understand what are all the transfer function of a system. Based on transfer function, you will be asked to find first order system, second order system, what is type of a system, or the one we solved like this, it asks you to find zeta, omega n, omega d, kind of this. You might have asked to find transfer function to system characteristics like this. Otherwise, system characteristics will be given and you will be asked to find the transfer function, like the one we solved RLC circuit, RLC, RC, whatever circuits we have, or dynamic equation they will give, like we solved a y double dot of t, etc. So this kind of problems might come. Then in week 3, what we have seen, most probably only like this. And important thing is in week 3, or I think we will get it in week 4. These are some of the problems that is important that we are going to solve right in the next week. Rise time, delay time, percentage overshoots. These are all like time response analysis. Right? So you have to study this also, how to find what is settling time, etc. That comes under this time response analysis. Then study about what is pole, zero, what are all the characteristics of poles and zeros. Right? And how changing one poles to another will affect the system. A kind of basic explanation about it that you can study. I think yes, we have covered most of the topics. Just go through the slides and solve the practice assignments and assignment questions. You will be able to solve the quiz. There won't be any problem. If you have any particular doubt in any concepts, or if you want to revisit some concepts, let me know. Otherwise, we can wrap it up.